Hi everyone, I'm Zhou from Rutgers University, and today I'm going to present our work called CellPred, a behavior eval scheme for cellular data usage prediction. There will be 4 different parts for this presentation. The first is the introduction. Let's go into that. And cellular networks, as we all know, is ubiquitous in our daily life. We can access the cellular networks for multimedia contents such as music, video, and etc. If you're on the road, then you're gonna use the navigation for a relatively long time. And we can also use the cellular networks for traditional business like phone calls and messages. And data traffic prediction is actually one of the major application in cellular networks. Previous works they focus on cellular tower level, and in this work we approach the data traffic prediction from individual level with the consideration of user behaviors. And the contributions of this paper can be summarized as we are the first study from individual perspective on cellular traffic prediction, and we consider user behaviors from subscription tags, which I will introduce later. And we propose this prediction framework by large data sets, which is cellular signaling data. And we consider the individual mobility and the usage. And we design this framework by software attention addressing behavioral tags. And in the end, we summarize some of the lessons learned through this investigation, and together with the limitation, generalization, and privacy issues. The second part is data-driven models. So that's the architecture of the whole pipeline. From the very beginning, we have the processing section, which will process the signaling data into user-based traces. Then we filter outliers and do some other processing to have the traces of mobility and the usages. By mobility, I mean different locations, and by usage, I mean the data traffic within a certain period of time. And once we have those trips, then we fit those trips into the prediction model for future location and the usage prediction. And at the end, we aggregate all the individual level data traffic into the cell tower level. Then it can be used for future applications such as location service and network optimization, etc. And that's the details of our modeling. And there are 3 parts: software attention, encoder, decoder. On top of the standard encoder and the decoder, we have the software attention addressing all the behavioral tags from different groups of users. By considering those encoded features of those tags, then we have a series of different weights on different groups of users. And by combining the features, the mobility features and the user features from different group of users and the historic location and usage, then we can better predict the future group location and usage. And in the end, we aggregate the individual level data usage to a cell tower level. And let's go into the evaluation results. And we have 3 different figures here representing the baseline comparison. And the first figure standing the detailed comparison of our CellPred together with other baselines. So during different time of day, we have the MAP representing the accuracy of different methods. The lower the MP, the higher the accuracy. So our CellPred achieves the best performance compared to other baselines. And the CellPred without here means the CellPred without consideration of those features that we introduced, including mobility features and usage features. And the second figure is corresponding to the first one with a bar chart figure. And the last one is the comparison between the CellPred without mobility features and without usage features respectively. And we can see that if we consider both features, the performance is the best. The next one is the contextual investigation. We actually have much more detailed evaluations regarding our CellPred. Here we just presented 2 examples to show that we consider other contextual factors. The first one is the different regions. So for different region, we consider the CellPred downtown area and suburban area, and we see that this CellPred performs slightly better in those suburban area because one reason may be that cell towers are far away from different from each other in the suburban area, while in the downtown it's relatively harder to predict which cell tower the user will be connecting to. And we also investigate the different day of week. So basically, we separate day of week into weekends and weekdays. So we see that during the first 12 hours, the performance is relatively comparable, and for the rest of the day, it's actually weekend. We can do better than the weekday. And let's go into the discussion last. So we are the first user perspective investigation of cellular data traffic prediction, and we're using 3 million cell phones and 23,000 cell towers to design a data-driven solution by considering behaviors. And we're also quantifying the impacts of different context factors. So for more details, please refer to our paper, and you can also access those two websites for more information. Thank you.